Why does the keyboard look like that? Hello? Oh, it's Jake the dog again. I remember you. What's going on, friend? Trying to get this type in. I want to be able to hit like 80 words a minute. Long term goal. Maybe even past that. Alright. Nine. This is so bad. Mm. Oh, shit, that was really bad. That was really bad. P193. Probably go. Oh, yeah. That wasn't. That had to be 60 at least. I was zooming. What? Strike rate. Average speed today was 51. It's pretty good. Typing is so slow. Oof. Oh, let's go. Are we done yet? Holy fuck. Yeah. We did it. Reached our goal. Next, we're gonna make some late code videos. It's on the agenda. I think I want to do some tree videos. Right now, we're gonna take a bit of a break. That's 45 minutes of active work. Where Chewies? Where are Chewies? Okay. Do I read the book on my agenda? I don't know. Or not read. We're on our first 10-minute break. We had to read the graph chapter. GRA. Alright, of course I'm playing chess on my break. Where my water bottle at? Alright, what have we got here? Looks like I'm meeting one situation. First back up to 2,800 trophies. Knight b3. Oh, knight b3. King d1. Knight b3. King d1. Knight b2. It's like here. I'm retarded. It was here. I was not able to like spatially see that. I'm trying to get better at that. White to move. White to move. White to move. You see a way to win the rook. See a way to win the rook. And he takes that to oh. Queen g6. Mate. Black. Did I calculate carefully? Be honest with you, bishop takes f3 looks really good because the rook on d1 is weak. It's here. If I can just infiltrate, like that just like makes so much more sense. All right, this is a moment of truth. How do we? What do we do? That does not look good. If I go here, he still checks me. I don't know. Take, and then I'm like, go here. And he moves us down. I can just get mated, honestly. What? What's the move here? I just block. I don't know. Sometimes I'm a little slow. Black to move is just mate. What? Yeah. Black to move. Then here. But what's the next follow up? Like maybe something like that? I don't know. Just took my bishop. 92? No, 94. 94? No. You know what's required because this is like because after 94, knight f6, and then you know queen h7 mate. Like, okay, he blocks that. Can I still do it? What if I went here first? What if I just went here? And then check. Take. No, it's not really gonna work. Is there something I'm supposed to be doing? Oh, duh. Black to move. What? Shit, I'm thinking. No, I can't do that. Alright. Queen F1 would be idiotic. Like Rook's pretty vulnerable. I think the Rook's actually pretty vulnerable too. Oh, check. Oh, is that mate? Oh, pawn checkmate's pretty nasty. Like to move. I think this is like the same spirit. White to move. Oh, wait, yeah. Oh no, it looked a little spooky. This is just a pen. You can find a way to win the material. Let's see, white. Going here, I could check. Maybe I didn't see a severity situation. I didn't think he was gonna sack his rook. He has 2 queens. That's not particularly good. What was that? I'm thinking here. White to move again. This just looks like me. Take. Ooh. Is this the move? This might be the move. White to move. Black King's pretty vulnerable here. Very uncool. Queen C7 check. That's not check. That's dead. This is taken by a knight. Thinking this looked like the only available move, Queen C5. Check. And there's like nothing you can really do realistically here, mate. What? What? Oh, go to block. Yeah, you're right. What the? Yo, I'm an idiot. What am I doing? I'm not an idiot. I'm just like doing some wacky tobacco stuff. White to move. Check. Take. My knight has some motion, but like that can't be good. What is this move? Knight G8. Could go here. I don't. Check again. That could be wrong. And I think that's just me. I shouldn't do that. If I go Knight G8, King G. There's only option though. Looks like a case of back rank checkmate. Yes, yeah, here. He dropped a. Oh, wait a minute, you're on your knight. Yeah. 5 seconds, so we gotta go back. Black to move. Right here, here. Right. Yes. Oh, to get your reps in, get the pulses in. Oh, that's easy. That just. What is he? Oh! Yo, that's what you get for going over the time. Alright, time to get another rep in. Alright, we have to make elite code videos now. We have to make elite code videos. That's. How many can we get done in our given time? I don't know. I said 3. Let's solve that one BST one. I had it open. It was like 2 some. And like. It's like some tree problem. Yeah. You're in a road manage 300k. Okay, so we just traverse once and add everything to a hash map. Wait, no. Add all the numbers to a map and just say if. And then traverse again, but at every node X. Yeah, that makes sense. Can I do it no side effects? That's like harder, but let's try. DFS, no. So it's like if not node, return. And then if not node return. But if it's, if it's a wait, I don't think I could do that. Because like, even if we got them, yeah, I don't know. If not, wait, if not, no dot left. Basically, I'm just saying if it's a leaf. I wish it was like an if leaf. If not, no dot left, not no dot right. There's a leaf node, so we should return. An array with node dot val. Then just return node dot val plus DFS left plus DFS node dot DFS. What the fuck? What am I writing? Tripping nuts. DFS node dot some shit like that. That would be like that would make sense. And then we just had to say check equals DFS root, and then we just say like another DFS function. I don't think I could do that. I don't know. pass? No. I don't know. That next. I'm gonna call it next. DFS. It's just gonna be called DFS too. And take a node and it's gonna be the root. I'm just gonna say if not node return. And then say if DFS. No. Yeah. If node dot val if node dot val I think true because 3 and 6. So if we get to this, oh wait, so if k minus node dot val, the problem is also an issue with duplicates because like imagine it's k is 6 but it's just there's only 1 3. It's gonna pick 3. It's gonna return true and there's no 1. How do we stop that from happening? Come say if k minus node dot val in check turn false. How do we stop it from picking up duplicates? Like, if this tree was k is 6 and this is like now 4. 6 minus 3 is 3. But it has to be 2 3s, only 1 3, so it's not good. That's not too good. How do you check if it's like gonna be duplicates? Do we just go? If not, no, return true, and then just go DFS. Not that left. Node dot right. So if we go DFS node dot left, DFS node dot right, it's a goal, and then we just say I should assign these to variables. And then we just say return left and right. So if they're both true, return true. One of them. The problem is that duplicate thing. DFS to the root. The issue is that has that same issue. K is 28. Oh, of course, that's false. How do we ensure that we're not picking up the same value twice? BST too? Doesn't matter. Oh, it is a BST. Oh, wait. A BST is strictly less than and greater than, so you can't have the same node twice. Wait, no. So this would work. I should just say if this, which is like the difference, is equal to node.val, we should return false, like, because it can't be. Okay, in my opinion, this should work for these test cases here. Let's see. Wrong answer. That's beautiful. Output 6. That's lovely. Why would we return? How do we get 6? Alright, you're losing me here. Not node return true. How do we get 6 here? Wow, I'm not getting bodied, but just gotta print. It feels good to get stuff right the first time, but you know, it's okay. Okay, so that's an array full of 5, 3, 2, 5, 3, 2, 4, 6. Why is 7 not there? Why is 7 not there? Why is 7 not there? Well, DFS not that left. DFS no dot right. Wait, what? Wait, what? Now I'm confused. Why is there no 7 here? 5, 3, 2, 4, 6. From 6, it's just like go dot right and get the 7. If not no dot left and oh. Okay, that gets the 7. That should fix that issue. Perfect. We're still getting values, which is interesting. Output false, expected true. So it gets the values. This works. Now we start at the root. If not node return true. We outputted false. Oh wait. Sorry. A little bit of a brain fart there. This should return true. Okay, that's good. If not node. Okay, so if difference in check, that means we found 2 numbers that should return true. If this one returns 6, 7? Not the meme, but like 6, 7. I'm not sure why it would do that. This clearly says return. It says output 6, 7. That's like weird. Five, 3, 2, 4, 6, 7. Oh, it's the same exact tree. Okay. But when K is 28, if it gets to not node, return false. What? Why would you return anything that's not a bool? That's a little weird, in my opinion. It should return a boolean. Wow, it prints numbers. It prints numbers. Where am I? Why would it print numbers? Why would it print numbers? It returns numbers? This returns numbers. DFS no dot left. If If not node should return false, and if it hits this, it returns true. Is it the orientation? I don't want to have to like look this up, but that's like a little strange. If not node return false. So left equals 3, 2, 4. And right equals 6, 7. Yeah, that's everything to the right and left of. I don't know. How is it? How is this returning numbers? If k minus node.val in check return true. That's like, that's so weird. What? But like, true. This reprints numbers. Why would this print a number? Left would equal a number? DFS note that left. Oh shit! DFS 2. Oh man. I was like, this that's like so like fucked up. I was like this. Oh wait, now. Okay. We can return now. Sometimes the smallest things get you. This should work. I'm still a little bit worried about the whole like duplicate number thing. I don't think it's gonna work because let's say the number is k is 6, and there's only like 1, 3 in there. It's gonna return true. But thing is, it's a BST, so there should be no duplicate values. Because the BST is strictly left and greater than and less than, so there should be no equals. I'm just gonna like store this in a value called like diff. Diff equals that, and then we just say diff, and we just say like, I think we just do like, if diff is equal to node.val return false. Because like, think about it. Let's say in this tree here we had k is 6, but this is like a 9 or something. Doesn't really matter. 5. Oh no, you can't have that. Let's just say a million. Doesn't matter. We'd say diff would be k minus node.val when we to 3, so it'd be 3. And we'd say if diff is in check, return true. 3 isn't, but we only have 1, so we should return this first. Because the diff and node.val are equal, we should return false, because that means there's 2. We need to have 2 nodes of the same value to supplement this, and the BST should not have 2 nodes, because everything to the left is less than right then. I think this works. Oh. I think this works. Wrong. You sneaky sneaky. I never cease to stop getting humbled by easy problems. Okay, let's use this test case. K is 4. I return true. Why would I return true? Why would I return true? If diff equals no dot val, we should return false. If diff is in check, I guess we got to the 2. Oh, wait. Oh, wait. Because 1 and 3. Yeah. Let's just comment this out for now. I still think we might have an issue. I think we're still going to run into a bug. Yeah, wait, what's this one? Root is 1, K is 2. Output true. Expected false? How the fuck? How do we return true here? If diff is in check. 2. That'd be 2 minus 1. Is that the smallest? Number of trees goes from 1. If it's 1, just return false. Right here. The length of check. If length of check equals 1, just return false. That should fix that issue. I'm still not like. I knew it. I knew it. Binary tree problem, man. Someone's probably like, if someone's ever like watching this, they're probably screaming at me saying like, "Oh, you retard! Like, why don't you just do this?" I don't know, man. I don't know. In this example, the node is -1. What two numbers equal -1? -4 and 3. So here we should say diff would be k, which is -1 minus no dot val Oh no, when we have 4, we should do k minus, so -4 minus, wait, what? I don't even know, man. What are we doing here? What node are we looking at here? So it's 3 minus -1 in the inside. 3 minus -1. Wait, no, it's -1 minus 3. What's -1 minus 3? That's 2. Right? That evaluates a 2, right? I'm almost certain. So it's not that. -1 minus 3. Oh man, this one's a bit tricky too. What's the answer to this? Because the answer is clearly like 3 and -4, that'd be -1. So when we get to -4, I would say is -1. How do you account for negatives? Like, it's a little bit tricky. We get to -4, and it'll say is -1 minus -4 in our tree. -1 minus -4? I'm pretty sure that's just 3. I think we should be fine. I'm pretty sure we're fine. I'm pretty sure. Why should this... Why would this print false? -1 minus -4. Oh my god. Print. Let's print diff and no doubt val. Feel like that. The difference here is -3. So we're looking at the 2 first. That's the root node. -1 minus 2. -3. Should be 1. What? -1 minus 2. Ay, ay, ay. That would just be -3. We don't want that to happen. Alright, and when node is -4, this should return true, no? It does -1 minus 4, which is 3, and 3 is inside. Why would it not return true? That is some goddamn mutiny. Besides the fact this is incorrect. -1 minus 2? Can we just store ABS, maybe? Where's the absolute value? But it's looking for K as -1. -1 minus -1 minus +2? That's -3? Really? Like -1 minus +2 is what? Fuck me. It's not good. Because that really should be 1. I could just do the other way. I could just say if K is negative. But I can't even do that because... Like, think about it. If I did no.val minus... Oh, I could just do plus. Like, if K less than 0... diff. And I should say like this is kind of like a crazy workaround, which is I'm not very proud of. And we can just do no dot val. If it's less than 0, just no dot val plus k plus a negative. That should be fine. I'm not very proud of that, and this shit might still not work, honestly. What's the issue here? I'm getting bodied. K is -4. Our expected true. What two numbers make up -4? Oh. -1 and -3. It would say that since k is less than 1, it would do no dot val, which is -3 plus k. Right. Shouldn't that be it? When it gets to 3, it should say no dot val. No dot val, so -3 plus -k. -3 plus -4. I'm a little confused. This shit's with the negative numbers, bro. They're dog walking me here. With the negative numbers, man, they're dog walking me. It's clearly these two numbers here, -1, -3. But what are we supposed to do? Like, what are we supposed to do here? We want this to equal -3. What if I make... This is so weird. What if I make k negative? What if I make... Can I convert all the numbers to just be positive? I think I'm just gonna convert all the numbers to be positive. Like, that just sounds like easier. Because just do 3 plus 1 is 4. Just don't put any... How do I how do I make it positive? I could do like a list comprehension, but I could rather just append them. No doubt, Val. Yeah, I don't know. That's just kind of crazy. Because if everything was positive, this would be nothing. Because it would just be like... That can't... What's the issue here? The difference between -1... If they're both negative, what do you want to do? How do we find the difference? -4 minus -1? What's that? What's -4? What's -4 minus -1? -3. -4 minus the node level is -3. But if k is negative, it does plus. So if k is negative and node.val is greater than 1, it's positive. I think this is an issue. Unbodied? Man, I don't know. I don't know. Right at 0? What's the treatment look like? Unbodied. Unbodied. I feel like this is such an easy like problem, but what the fuck? So the difference is -4. Is 0. I don't know, man. We got 0 and the k is what? -4. 0 minus -4 is -4, okay. Then it goes to -1, and it says that the difference between -1 and -4 is -3, which is in diff. This should return true. This is correct. This should return true. Next we go down to the 2. -2? We're at -1. Now we go to the 2. Difference between -4 and -2. Difference between -4 and 2. This could be 6. I don't fucking know, man. I'm cooked. I don't know why this doesn't return false. True. Like, this literally is like, this should be true. Wait, we got one true. Don't tell me it's just an OR thing. And all the other ones just like had 2 trues. Oh, this is false. It didn't even print anything. Please tell me that's the answer. After getting... Yo, you motherfucker! There has to be an easier way to do this. I'm like running into problem after problem after problem. I thought this was going to be so easy. K is 6. I return true? I return true to this? What the fuck? How? Where would I possibly return true to a node like this? Alright, let's run this again and get the wrong answer. Why would I get... Oh my god, it's the same fucking issue. I knew it. I had a line here that literally fixed that. It was like if diff... Wait, did we make diff yet? No. If diff is equal to no.val, turn false. That's what it is. Because you can't have two of the same nodes in the tree, like... Oh my god, we got one right, and now we got one wrong. I'm so close. But that broke this one. So in the tree 1, 3, 2. Look, 1 and 3 both out of 4. Say what's... What's gonna happen here? What the fuck? Let's say is 4 minus 2. Is that in there? Oh. You can't just do this. You can't just do this. If diff equals no.val, because the diff equals no.val here, but there's more. You have to continue checking. Man, they sure know how to make a hard problem. How do we fix this case without messing it up? Wait, hold on. What if we just if diff is not in no.val? Don't return false. We say if diff is not equal to no.val, we can now check this. This is really bad code. This is like you took a poop on the site. This is terrible code. It works, you know. And just like that, I'm out of here. 420 out of 423. What type of malarkey are you pulling? I don't even know what this is. This tree is huge. Expected output true, expected false. Man. You got me. I don't know. If diff is not equal to no.val, because if it's equal to no.val, you just shouldn't check it. It's fucking wrong. And if then we should talk. All right, I'm gonna use this test case. I'm gonna test it out. If I were to get rid of this is supposed to be an easy problem. Like, I kid you not. If we test this out, Do I get that last one right? No, it's always wrong. So this is just making progress. Yeah. It's just this problem. I don't know what this even looks like. Um Yo, you're shitting me. Data's too large to display. This fucking tree is enormous. Apparently the answer is true, but I got false. Alright, 45 minutes has elapsed. Um, you know, it was good while we lasted. We're gonna have to actually answer on that one. It's about ChatGPT on. It was fun while we lasted. Yeah, I'm getting bodied by a twosome. Is like right now your code is a bit tangled because you're calling DFS on the root twice. Wants to get the check, then again at the bottom. Wait, what did I do here? He just does a scene set for val and values if what was wrong, mine? You're trying to check if there are two different nodes in the base2 value sum with decay right now. You're the big tangle. You're calling DFS root twice. Once to get check and then again at the bottom. Oh, that's weird. I don't know why I did that. We didn't need to do that, but that shouldn't. Yeah, it shouldn't fuck up anything. You're using diff in check without guarding against counting the same node twice. So he just deletes this whole thing. And he just says, okay. I mean, if you want a pure DFS solution without building a list, you can also do this. That's crazy. I'm gonna look at this later, but why do we have a set scene? If diff is in scene. Oh, it's like that one pass solution. Yikes. I like what you're doing there. Wait. I'll fix mine though. Check contains all the nodes, including the current node's value. So diff and check adds can add excellently match the same node. Isn't that what this does? Right. I get why you had stopped pairing your node with itself. The problem is that it also blocks a valid case then the tree actually has two nodes of the same value. Oh. Oh. This way, if diff... Oh, shit. That's like a double H case. I can't do that. Okay, okay. What do you do here in DFS 2? Temporarily remove the current value so we don't match it with itself. Check dot remove no dot val. I like this better. Remove. Oh yeah, I guess we could do that. I guess that's like... I guess that's like cool. And then the other issue is that... Yeah, that makes sense. And then you could also, if diff is in check count diff. Oh shit. We have to count the diff. Forgot there's a counter. Is less than 1. If diff is in check, if the diff is in check, and it's greater than 1, return true. And if diff equals no dot val, yo, you gotta explain this. You explain this. I don't understand what the fuck they're talking about. This part checks whether a node exists, whether there exists any node value in your check list that matches diff. Okay. If it's not there, the whole condition is false. We're checking how many times diff appears in check. We want to make sure it's not pairing itself to node. Okay. If node dot value, that means we're pairing. It means we'd be pairing the node with itself. In this case, we need at least 2 occurrences of that value in the list to form a valid pair. So greater than 1 check. This seems like overly complicated. Does this work? I feel like this does not work. This works? Boy, oh boy. Wow. I didn't think about just removing it. I'd never thought about just removing it. Low as fuck. I never thought about just removing it. I would never do this. This is complicated as... Can you... normally, like... Okay, thank you. So if diff is in check, we want to check that it's... If it's equal to no dot val, we have to see that there's at least 2 of them. So if the count is greater than 1, return. Alright, else... Else, okay, yeah, that makes sense. And they showed some other ways to do it too. Here's some cool stuff up in here. The remove thing, I like. Oh, there's this way too. If diff is not equal to no dot val, and diff is in check, return true. That stops the whole problem if there is to. If diff. Doesn't this have an issue? What? How is this not? How is this like valid? And here it does a set. It just goes through the values. It has the diff, and if the difference is in the set, we return true. And if it's not, we add it in. So we have a okay. All these approaches make sense, and then the pure one is here's a set. If not, don't return false. If the difference is in scene, return true. Scene that add no dot val. Oh. Okay, I get that too. How does this stop? How does this stop? If difference is not equal to check? So it does fail. Yeah, okay, yeah. Damn, that problem was that was not fun. Got my ass handed to me. I'm gonna have to redo that. There's some fun stuff going on. Why is my music muted? Let's go Reddit. Not Reddit. 1213. Is that Karu? With the burgers? Karu with the burgers? Games 4,747. Do I want to win a game? I feel like. Can we push to 2,800? I'm smelling some of this. Black to move. That's just mate versus unit. I'm pretty sure we go here. Wait. Hold on. Take. Check. Bing. What if I go take? He takes with the queen. Seems like an issue, no? Maybe this is the move. Take. Where's the take? Yes, that seems more like smart. This is not mate. This is not fun either. This is absolutely mate. White to move. We need like a crazy firepower. I'm thinking like take, then take. Yeah, that makes the most sense. We just gotta like battling ram. It's like FBI, open up. Take. Yeah. Oh shit! What's wrong with my ass? I'm so lucky that that worked out for me. What is this? Is this a blunder? Our bishop's like totally not. Alright, we have this nice check here. Block, take. And then he's starting mate, yeah. Oh! This is new. Actually, here I could take a check and then pick this up. I'm an idiot. What the fuck is wrong with me? Like, I was trying to be too fucking smart. Like, what? I thought it was like some grand plan or something. 2800, let's go. I mean, check, take, check. And that's, they're dead. Yeah, that's like. Alright, we had 2800. For me, that's good enough. My puzzles are getting decent. Puzzles are getting decent. My puzzles. 0.05. How many hours over the last year? Well, May? I was just sitting around 18. I think that's where the puzzle inflation came. Puzzleflation. Our goal is to win this game. The Indian game. Alright, we're playing the semi-Slav defense. Bing, ba boop, ba doop, ba doop, ba doop. I get the bishop out, close up. Ooh, close up. Okay. Do we take immediately? Or do we like try our chances? Is this like a thing? Expanding like rapidly on the queen side? Like, I don't know. I don't know if that's like tried and true. What could go wrong there? I don't know. I haven't should I just pressure, or I could just pressure this? Pressure here. I don't know. That just doesn't really seem like that. Like, how solid is that really? I think this is the most safe way to play this. I don't know, don't at me. I don't play the semi-Slav often. What is this? What is he? Is that blunder? That has to be blunder, no? That has to be a blunder, right? I don't know if I want to castle into that anymore. That changes like, and then he also has this. If I push kick now, we're gonna have this like this light squared bishop problem. If we ever, I don't think I'm gonna just kick castle there though. What could possibly happen? Is there like an issue like take rook g1? I don't fucking know, man. I don't know. I might have the castle that way. I don't know. I might have the castle. He castles queenside too. Am I a fool for this? I can't castle into that. It's like too dangerous. Yo, hold up. The magic might happen. Check. What? I need to. Oh, it's pinned. That's not too good. Can we get this fucking knight off of us? Can we get this dumbass knight off? You would need some like crazy maneuvers. He doesn't have a light dark squared bishop, so he moved it. And I don't have a light squared bishop, so I can't get that off. I'm pretty sure if I castled queenside, my king would be here. And then I just lose the queen like that. That's like retarded. Yeah. I guess I just gotta be like in the middle of the board. That's how I'm playing this. Let me stop. In the center of the board. He could back up. I don't know. Nice. Yeah, okay. We just take. I feel like take. He would be able to take that. What is he trying to do? Take. I need a knight here. Or something. What if I took take? Wait, is that possible? Here? Is that possible? No, I can't do that. I could castle, but I don't know. It looks a little spooky to me. I'm fully expecting, not sexting. I still feel good. Knight d5. Knight d5. Take. I feel like my P's and Q's are covered. Maybe a spicy check here. I could just easily win a pawn. But is that what we want? Is that deadly? Is that cocky? Can something go terribly wrong? Or should I just come here? I don't know. Something could go terribly wrong. I don't know. No. What would I take? Check. You wouldn't be able to take this because of. Yeah, I think I'm fine. Even if they check. Queen b4 is not deadly. Because my queen on f3 protects. I was not looking at this specifically, but when I'm up 1 point of material, possibly going to be up 2. Should I be worried? Am I going to regret this decision? What can you do to me? I'm running low on time, so I think simplifying the game will be the most practical. I didn't really want to, but he wants to trade immediately. I don't think you could win with down a pawn like this. Rook's on the 7th? No. Even like here, I think he's forced to trade with me. And I'm up a pawn, like I just think it's a winning endgame, I think. I think this is just a winning endgame. You can't go into this endgame winning. He knows. He knows. There's no funny checks or anything naughty that's gonna happen. I plan on like pushing up. What if I push here? You'd have to move out the way. You have to move somewhere. You can't stay there. Surely not. You're an idiot. That game is over. It's over. There's nothing you can do to save this position. You're better off just trading with me earlier in the game. I had a blunder. Oh yeah, I probably played like Scheisner. 1700.
Opening with the queen's pawn controls. You permitted the opponent to capture a pawn and win material after the follow-up trades.
Oh, because what? Take? They win. You shouldn't take. What? Take with here? Oh. Yeah, there's like nothing I can do there. He is actually winning.
That rook was yours for the taking.
Holy shit, I blundered.
Nice, definitely the right move.
Wow.
You permitted the opponent to capture a pawn and win material after the follow-up trades.
I'm thinking like this has to be a better move.
The piece finds a new active square.
Is there something better? It just says this is good. I didn't get excellent or great. What do I think's a lot better? I mean, to move. What? That's better? I'll take what I can get. I'll take what I can get. Okay. That was fun. Now it's time to go back to studying. This problem is so fucking silly. We should be able to solve it like pretty fast now. It's just like thing equals set and then def and then df dfs node, if not node, return true, and then just say like, and then we just say like if k minus node dot val in scene return true. This should return false. return false, and then if k and no dot value equals c, return true. Else we could just do scene dot add no dot val and then BFS no dot left no dot right and BFS root, some shit like that. Oh. They're not really returning anything. And then left or right. I think this makes sense. Yeah, okay. Okay, we actually were able to figure that out. Getting bodied on tree problems definitely doesn't. It definitely kind of sucks. It hurts the ego a bit. But you know, it is what it is. Depth for search, I have 330 problems. I bet there's a lot of overlap. We're at 56 of these. Difficulty? I think we've done every single easy one. This was hard as fuck. Second minimum node. Oh, we got like a couple easy ones to do. We should be able to knock these out. Give a non-empty special binary tree considering all nodes with a non-negative value where each node is this tree. Oh, I need water once I mouth is funny. Alright, we are back. We've been streaming 2 hours already? Wow, that's great. Alright, where each node is exactly each node in this tree is exactly 0 or 2. 0 or 2 sub nodes. They mean children? If the node has 2 sub nodes, then this node's value is the smaller value among the 2 subnodes. More formally, the property root.val equals the min of root.left.val and root.right.val always holds. Given such a binary tree, you need to output the second minimum value in a set made of all nodes values in the whole tree. So given such a binary tree, you need to output the second minimum value in the set made of all nodes. The second minimum value? Okay. Root.val is equals the min. Okay, so there's 2, so 5. Oh. What? This is kind of stupid. You can just go. Is it always going to be like going the least number in the top? Is it a BST? It doesn't say it's a BST. It could be like. This could be like 7 up here. Put in array, sort it. Put in array, sort it, and then return. Put it in a set, sort it. And return the second value in the set. Like, I don't know. Like, I would just do something like, can they give us a 0 nodes? No, at least it's a node. So I'm gonna say if. No, I'm just saying, so like DFS, def, DFS, node.val, well, node, and then like, if not node, return. Can't spell today. Return. If not node dot left and not node dot right, return. It should be like a set. Can you add 2 sets together? Shit, I don't know. And then just do return DFS. No. This in a set. Node dot val plus DFS node dot left plus DFS node dot right. Does it always do pre-order? I don't know why. And then set equals DFS root, and then it's like if the length of set is equal to 1, return false, and then else what we want to do is get the second value. All you do is really convert this into an array. Do we have to do that? I don't know. I'm just gonna be safe. I'm gonna say array equals the list of our set, and then just return. Array equals the list of our set, and then array.sort, and then return array at index 1. Oh shit. That makes sense. Well, yeah, but if it's only 1 value, so return a 1. But it's 2 values. That makes perfect sense to me. Fucking. Oh, RAT return. Come on, first try. I'm still counting that as first try, honestly. Unsupported operand. Oh, you can't add 2 sets together. That's very sad. Wait. Actually, because it's not like cheating. This is learning something new, I think. If not node. Oh. I kind of like this, but is that the issue? I think that was the issue. Is that the issue? Because it was returning nothing? No, you can't. Just can't. Can we do this with a... I could just convert it into a set after. But here's an important trade-off. What happens when you use a set? A set will remove duplicates automatically. That means that oh, I see. Why can't you use plus like in a list? If it was like bar thing, you can't use plus in a set because set objects don't support concatenations like lists do. There's no plus operator because sets don't have an order and don't allow duplicates. To combine sets, use the union. A.update. A.update be an in-place union. So a union of sets. Wrong answer. Oh. Return fun. I kind of like this. We're into a list first, so he carried them all to a list. Oh. What's the difference between these two? I don't know. It's mainly whether it changes the original set or not. The union operator creates a new set containing all of elements A and B, does not modify A or B. Oh, okay. So A, B, C equals A plus B, so C is A, B, C. Okay, unchanged. In place modifies A directly, so A update B. Okay, that makes sense. What is this question? Second minimum node. Wait, attempted. I failed this? I was kind of like hype as hell. I was over counting chickens before they hatched. 5-8. 5-8. 5? What's the answer supposed to be? 8? Why would I return 5? Because you did not sort correctly, my friend. I'll do it to you. Yep, I'll do it to you. You need to actually learn how to use the sort operator. Oh, okay, that was pretty good. 340. Okay, that's pretty. That's good. I'm gonna use the rest of this time to. I'm gonna use the rest of the time to message some people. So LinkedIn. Okay. Oh, okay. Um. Uh. See you. Uh. invite was received. See you Thursday. All right, boom. That's one. How it feels to let the IT control your desk. That's insane. Okay, we gotta check our network. We're LinkedIn grind maxing. We gotta check our emails too. We're really good on time right now. 140. That's 144 already. Man, time flies when you're having fun. What do I say? We got a couple of messages on LinkedIn. Clerk. Yeah, we got some good stuff in there. Check my other. I think we need to respond to people on LinkedIn because that's important. I don't owe any. September 2nd. So I don't owe any money. Let me make sure I don't owe any money on my credit card real quickly. Okay. We're good over here. When do I owe my credit card? I owe $22. One's for September 15th. I feel like I'm pretty good on that. And then my Apple Card. How much do I owe there? $357. That's not good. Okay. Weird. That's not good. We need to really get that settled. I lost email access. Gemini has not reached back out to me. Then like, then August 9th? The 9th? That's Saturday. It's only Tuesday. Onward and upward. I'm gonna give it some time because it's only been a couple days. It's only been a couple days. Okay. Now it's time to message people back on LinkedIn. Hell yeah. I think I'll I'll take. Okay. I was thinking the same thing. Hopefully Thursday. Hopefully, Yo, I got like crazy amount of. Dude, I got like. You have like. What do you? I don't know. Like, you were doing. Oh. Into YouTube. Also gonna be in action. I mean, I saw them in action. Actually, when you going to? I'm gonna focus on DSA. Did you? Medium. Well, maybe I don't know if I typed it correctly. Oh shit, dude. Grinding. I'm grinding so damn hard. Alright, so we do like LinkedIn shit all day. Oh, it's fucking scammed. Boom. Okay, we just sent out a bunch of messages. Go look at this. National. Oh shit. What's this? August 16th. 16th. What day is that? What day is the 16th? Saturday? This Saturday? Oh man. Alright, I think we've done enough. That was like that was it on that shit. Done enough LinkedIn. Let me check Slack. We always gotta keep up with our like messaging people and stuff. Even though I'm not hating, it's just like a lot of shit. Okay, nobody responded. Is good, so we don't have to worry about that. I think. All right, so we did all the responding. Alright, now we just have to record videos. Okay, we have to record videos now. What leak code problem are we gonna make a video about? I want to change my shirt too. What leak code video do we want to make a video about? To some 4 input is a BST. What's the difference then? Yeah, I feel like that's pretty simple. How would we explain this? Five, 3, 2, 4, 6, 7. 5, 3, 2, 4, 7. Bang, bang, bang. Okay. K is what? K is true. K is true. I'm high, so K is 9. So K equals 9. People send me some invites to connect. What are they talking about? Why am I getting stuff? My boy. Amazing. Oh my god, these niggas are getting jobs. Oh, brother. Where do I need to apply to? I need to apply to like some new job or some shit. Fucking hell. I don't want to be tech fail. I record. I need a job. Like, live. You know what I'm saying? Support. Like, help support. Like my dream job. Okay. So what we're gonna have is this. Would this work with an array? I think it would, but we just do like so we have a set. So what we're gonna do is we're gonna have a set. And we're gonna go through and we're always gonna add the difference of the node we're at. The difference between K and the node we're at and add it to our set. And the difference is already inside of the array. That means we found a match. And that means we found a match. For example, if since k is 9, let's say we add 3. The difference between 3 and 9 is 6. And once we get to the 6, we'll say 9 minus 6 is 3. Wait, what? 9 minus 6 is 3. Wait, what? Wait, hold up, what? Wait, what? Am I tripping balls? We're just... If it's n seen to return true, that's just add to our value. So how should this be traced? We're gonna go through, we're gonna see. Is 9 minus 5 in our set? It's not, so we add it. 4. Is 9 minus 3 6? It's not in our set, we add it. Is 9 minus 6 is 3. 9 minus 2 is 7. 9 minus 4 is 5 minus that. 9 minus 7 is 2. No, we can't be storing the difference in here. Right? Like, that doesn't make any sense. We had the node.vel. We're going to say, is the difference inside of scene? If so, return true. If not, just add the node.vel. So let's say we come across the 5. We say, what's the difference between 9 and 5? 4. 9 minus 5 is 4. Is 4 inside of our set? No. Is 4 inside of our set? No. So we add the 5 in there. Go to the 3. Let's say 9 minus 3 is 6. Is 6 inside of our set? No. So we add our 3 in there. And eventually we do these two numbers. But let's say we're doing a breadth first search. We get the 7, the 6 now. 9 minus 6 is 3. Is a difference inside of our set. 3 is here. The difference of this is 3. We return true. And we return true. That would be the answer. I guess it required me to stop recording for a little bit. I mean, I could do that. It's not. My microphone has no signal? You lies. There's a difference. If the difference of the node in K is inside the difference of the node. So we're adding nodes. We're adding nodes that have that difference. Now we know 3. There's some node in our tree. That means there's some. Two nodes both have the same difference. And then we add 3. So this means that there's some node. What the fuck? Did I just fucking delete everything? Yo, what? That's insane. That is fucking insane. That is absolutely disgusting. That is fucking preposterous. Everything's been deleted. Okay. we come down to 3 and we see that the difference between 9 and 3, the difference between 9 and 3 is 6. So we're gonna add 3. Six is currently not in our array, but we're gonna add 3 because now, but we're gonna add 3 to the set. What does that mean? Oh, I felt like I thought we need a hash map. You just do it with a set. It's a little. It's not in there. We add the number. And the difference between this between 3. Oh shit! I would have done a hash map and just had like a set, and this would be the difference between 4 and 1 is 3, but it's the difference between 4 and 1 is 3. Is 3 in our set? It's not. So we're gonna add 1. What does that represent? We're gonna add 1 because that's a possible number that we can add to another number in our array to get k. So when we go to 4, when we go to this, we go to the left and we get this 3. Let's say k, which is 4, minus 3 equals 1. That means this number plus 1 will give us k. 4 minus 3 equals 1. So what that's saying is, oh, animation with, somebody said hi, hello. So this is 1. So what we're saying is, so we want to query our set now. Is there a number in our set? Wait, what? I'm sorry. So we want to say, is there a number in our set? Is this number in our set? Because that means this current node's value plus that number, which in this case would be 1, equals k. Oh, that makes sense. Okay. That's actually pretty cool. It said hi. Oh, so someone just subscribed? Oh, wow. How kind of you. Are you into data structures and algorithms? Is that your forte? I'm about to record a video really quickly, going over how to solve this problem. One, three, 4, and then I don't think chat pops up on screen. You're not gonna read what you're saying. It's not Twitch. Dude, what the fuck? It always does this until you lose everything. Excalidraw is fucking broken. Like, I have no clue. Like I don't know. This shit's like really, really broken. Done 3 and done 4. In this example, k is, let's say k is 4. And let's say k is 4. We're gonna figure out the difference between k and the current node that we're at. And if the difference is in our set, we're gonna return true. If the difference left and right. And if the difference is not in our set, we return false. And if the difference is not in our set, we'll add the number and continue. And we have to store the left and right. What are you learning? This is data structures and algorithms. This is the question. Given the root of a binary tree and an integer k, return true if there exists 2 elements in the BST such that the sum equals to k, otherwise, or false otherwise. I'm gonna make a video on like explaining how to solve this one. I think we're gonna go through, check the difference. The difference of 1 and 4 is 3. Is 3 in our set? No. So we're gonna add the value 1. So if we ever see another node where the difference is 1, that means that these two nodes are pairs and they add up to k. So let's say we go to the 3. We're gonna say what's k, which is 4, minus 3. That equals 1. We say, is that in our set? It is in our set, so we'd return true. Let's put a little green ticker here. So that means from 1, when we go to the left subtree, this would return true. But that's not the end of the program. Next, we have to go to the right subtree. We'd say, what's the difference between 4 and 4? 4 minus 4 is equal to 0. Is 0 in our set? No. So we add 4. Just solved. I'm pretty sure I have to return. I have to return like true. This would be 0, so we add 4 to our set. And now we're gonna call the left and right on 4. You can't see them, but left and right has a left and right pointer, but they point to null. So I'd indicate that with red. We say DFS node.left. And our base case is just going to be, if we reach a null node, return false, because yeah. If you hit a null node, the base case should be bye buddy, peace. If we reach a null node, return false. Because we can't subtract k from null node. So this return false. Same thing on the right, return false. And now we know that from 4, the left and right subtrees both did not find any 2 nodes that sum to k. So we're going to return left and right. So we're going to return left and right. Left or right. Because one of them is true. So as you know, false or false returns false. So this will recurse back up and return a false. Now, from the one node, since every node is completed and we're doing the last node here, 1, this is actually pre-order. Can you do this? Because I would like to explain it in like that. Can I do it in pre-order? So I have to do. Because we're actually animating it first. That one node. That would actually make this actually is how we did it, because it goes here and then it's left and right. Yeah. And then we want to know if there's a match between the left or right subtrees. So from the 1, when we recurse back up to the 1, we're here. When we recurse back up to the 1, we're going to return left or right. The left found a match, so that'd be true. That'd be true. Or false. True or false. So this will return true or false. And remember, the OR operator, the OR comparison operator will return true if one of these evaluates true. So as we see, we found a match on the left subtree. So this function call would return true. This function call would return true. That makes sense to me. Holy shit, I've been here so long. Holy fuck. Time flies. And you're just having so much fun, eh? E4. After I record these videos, I think I'm gonna eat. I'm playing a Carl Khan, but I'm black. I'm white. Is he planning something like this? It's very rare, I feel like, when they don't trade their bishop. It's a lot of pressure on his weak square, c2. This is my good bishop. Here. I don't really know. This is good bishop. I guess I honestly would be happy for him to trade that. No fun attention. If he trades with his knight, that's That's fine too. Yeah. If I had my rook there, I could have had like more pizzazz. Is Ismail? Yeah, what's good? Check. Block. Take. Are we fucked right now? I don't know. I feel almost the need to do this. Ismail. Is male. Is male. Are you male? Where is the male? He's in a castle, right? Yeah. You're like a fool now too. Put your rook in E8. Put your rook E8, I dare you. Put your rook E8, I dare you. Triple dog, dare you. Oh, he jumps in. Knight for knight. This is kind of funky. Take. Ugh, it's kind of annoying. No, yeah, this is like weak. I could either here or put my queen here. Is that queen here like viable? I don't know. I'm kind of starting to feel the pressure. Yeah, I feel like this is not like the best predicament. All my pieces are on like the back rank. We need to stop mate. But then he just comes here. It's like the only way to stop getting like mated instantly. I would prefer not to get queen h3. Oh, he could do that. No, that's you can't do that. He returns back up. He's gonna try a new vector of attack. What is that, you may ask? Shit, I don't know. Am I cooked? We are not doing phenomenally. We could force a little like bishop trade, you know? That's a blunder. That's a blunder. Unless like he has some secret plan, but that's just a bad move. I saw this. Not exactly played out like this, but I was hoping he'd just take here. I'm gonna win the bishop on the light square bishop, but he's trying to take my bishop or this pawn here. This would defend literally everything. But what if I went here? Take, obviously. Check. Here. And there's kind of like nothing you could really do from there, in my opinion. And take it, take it. It just seems like a good move. I don't know. What's he like? What's he gonna do? What's he do against that? Like, that's just a good ass move. I'm still gonna go queen g5. Still gonna go queen g5. What is he threatening here? What the fuck? Do I understand what his like thought process is? I don't think I honestly just, like I don't think I get it. I don't think what is his plan? Is there some type of amazing plan? Because take. Like, that's not good. I don't know. Here? That was kind of a dumbass plan. I should have went. Um, that's not too good. He abandoned the game. I don't think I played that like the best. We played a Sicilian. Oh, I thought we were playing a Caro-Kann. I'm pretty sure. That's tactically wins a bishop. What? Wait, so
This move is nice.
how do you?
Moving there. Nice. You found a way. Moving there threatens.
So if I went
This is the way to
here,
win a bishop.
what if he just goes here?
The game was close to equal, but now white has the advantage.
Oh. Oof. Yeah. There's some deadly stuff going on that diagonal. Super deadly stuff going on there. Okay. Time to record a video. We K equals 4. All right, so we say K equals 4. What's that? It's like showing the chess under the board. Crazy. Here we have a set. One way would be to grab all the nodes in this tree then have the two nested for loops iterate through, checking every possible combination. But the problem with that is it's O of n squared. Can we do any better? All right, gotta record this video. I'm gonna change my shirt, but the render shirt. Do I look homeless? I don't know. Do I? Like low key. Low key. Low key. Let me get my. Holy shit, I don't know. Fucking Friday. Because I feel like we gotta at least record some videos. We gotta at least record some videos. It shouldn't take too long to answer this question, but, you know, knowing me. We could even get like 3 of these done today. Golden. We should be good. Let's get it. Wish I could remove this solve thing. I wish you could do like remove that. Open image in a new tab. Let's try to download the thing. What the fuck is that noise? Um 39 years, $dollars a month. Expensive as fuck. 30 days of JavaScript. Can I remove my like second minimum? No. I don't think you could like remove your like thing though. I don't think so. Whatever. Whatever. Alright, so we gotta make this like big. Who's sum for input is a BST. Can traverse the tree. Count all the nodes. Wish I could like draw on my screen. That would be so cool. Like, how do you do that? Does ChatGPT know? Is there a way to draw my PC screen for free? Epic Pen? EpicPen.com. Let's see. This would be a virus. Start your few trial. I feel like pen eraser and highlighter. Get quote. I already don't like this. Like that's too like industry free. They're pretty cool. Epic Pen. I swear I never applied for a senior Scrum Master. I don't know. They say you have something called Windows Shift S. Windows Shift take a. Oh hell no! I'm not doing that. Epic G Pen. It just doesn't sound that fucking cool. Look at that shit. Look at this shit. How does it work though? Just try it. I'm gonna just try it. I don't know. I think it would be cool to like download straight on. I hope this is not some crazy like adware. Started on Windows login? Probably not. I didn't even apply for a senior scrub master. Um, See, they're already doing too much. Yeah, uninstall this shit, please. I could like tell it was terrible. Like I could fucking tell it was terrible. 300 megabytes to draw on a screen. Like Nick, you trying to charge me to draw on a screen? Like that is insane. $2 a month? Bro, it's drawing on a screen. Like there's just no way. Epic GPen installer, delete that shit too. I just like, I thought I should stop recording and then like record a new one. Set this 45-minute timer. How many videos can we get out in 45 minutes? That is the question on everyone's mind. Okay. I should be good. Got my render shirt on. I'm pretty sure this chair is backwards. Yeah, definitely backwards. Okay. Maybe I should like be like low key a little lower. Code 653. All right, hello everyone. Today we're going to be solving LeetCode 653. To sum 4, input is a BST. Given the root of a binary tree and an integer k, return true if there exist two elements in the BST such that the sum equals k, otherwise return false. So as we can see in this example here, 6 and 3 together, or the sum of 6 and 3 is 9, k is 9, so we'd return true because there's two nodes that equal k. So how do we solve this? I think the first would be like a brute force way. Let's see. I think that's the most simple and most easy to understand. So let's say we just traverse the whole tree one time and got all of the values and add them to an array. Something like this. Then we have two nested for loops that's going to find every combination of two numbers in our array. And this will result in the right answer. But it would be big O of n squared time complexity, because as the tree gets bigger and the number of nodes increases, we're doing exponentially more operations because we have to compare every node to every other node in the tree. Can we do better? The answer is yes. We have the same exact tree here, well, slightly different, 1, 3, and 4. And what we're going to do is use a set. And we're going to use the depth first search traversal algorithm. So make sure you're familiar with that. First, we're going to check the left subtree. Well, first we're going to look at the value we're currently at and see, is the difference of k and this value in our set? If it's not, we're going to add this value. So the difference between 4 and 1 is 3. Is 3 in our set? It's not. So we're going to add 1 because 1 could possibly be the difference of another node in the tree if there's a match. So we add 1 here. Next, we go to the left node and we say, do the same thing. Left, 4 minus 3 equals 1. And we say, is 1 inside of our set? 1 is in our set, so that means we know that 1 and 3 add up to k, therefore this is true. So what we're going to do is return true here. I'm going to put a little t here. And since this is a recursive algorithm, we're going to have a base case. So from 3, it's going to try to go left and right. And as you can see, these are both null nodes. I just didn't write them. And if you hit a null node, what we want to do is return false. So this would be false and false, because you can't add anything to a null node. And after it returns the left and right subtree, we want to return left or right, because left and right will both return booleans, and the or operator or comparison operator will return true if one of the values is true. So if left and right are both false, that means there was no matches found on the left subtree and none on the right subtree. Therefore, there's no matches in total. But if one of them is true, then we should return true because the match was found on one of the subtrees. So false and false will return false. Now we have to go right. So we'd go right to the 4. We'd say, what's 4 minus 4? 4 minus 4 is 0. Is 0 in our set? It's not, so we're going to add 4 to our set. Same thing here. These two have null nodes, so these will both return false and false. So this returns false. Now, from the 1, we have a left subtree that returned true and a right subtree that returned false. And since we use the OR comparison, we're going to return right or left. So this will return true because one of them is true. And we end up only doing O of n operation instead of O of n squared. So this is actually much faster. And if it doesn't make sense here, we're going to code it out and walk through every single step, and hopefully it'll make even more sense if any part is confusing. So first, what do we like to do is create our function DFS. So define DFS. It's going to take in a node, and in recursive functions, we always have to make our base case. So if not node, return false. This is essentially what we're doing here, and not returning false if we hit a null node. Oh, almost forgot. We need a set, so we're going to say set equals set. And now we're going to find the difference. So the difference would be k minus node dot val. So this would be the difference. And if we say, oops, if the difference is inside our set, oh, got the if statement. So if the difference of k and node.val is inside of our set, we want to return true, because that means that we found a match, the current node, and we found another node that had the difference that is the same. So that's the same as here. If we see the 3, we'll see that 4 minus 3 is 1. 1 was in our set, so that would return a match. That's what we're doing right here on this line. Next, what we want to do is have 2 variables, left and right, and these will represent the left and right subtrees. And we want to know, and they're both going to return Boolean values if they found a value that's 2 values that sum up to k or not. So left will equal depth first search node dot left, and right will equal depth first search node dot right. And lastly, what we want to do is return left or right, because we want to know return true if one of these evaluates to truthy, and if they both evaluate to false, then return false because there's nothing to find. So now all we have to do is say return DFS node root. Let's do the root here, and this should be all we need to solve this problem. Let's submit it and see what happens. Are we lucky today? Let's see. Wrong answer. I can't say I'm fucking surprised. What happened here? What happened here? He must have done something stupid. DFS node, if not node, turn val. Left equals DFS node dot left. Right equals DFS node dot right. Oh, we didn't add. We never added anything. Yeah, that makes sense. All right, let's clear that. All right, so here we are at the code, and we're going to code this up quickly. All right, so here we are at our text editor, and we're going to code up the solution quickly. So first, what we need is a set, because it gives us that nice O of 1 lookup. So we're going to say set equals set. Next, what we're going to have is our function. So we're going to define the function, call it depth first search, because that's the traversal algorithm. It's going to take in a node, and here's our base case. So if not node, return false. And we're doing that because, as you remember, let's say we get to a node 3 and it has no children. If we go left and we hit a null node, we just want to return false because it's impossible to sum up to anything with a null node. There's no value. Next, what we want to do is check is if k minus node dot val in set. So we're checking if the difference of k and node is in set. What we want to do is return true, because let's say when we're at 3, the difference between 3, 4, and 3 is 1. We checked our set, it has 1 in it, so we'd return true. So that's where this big T comes from, because we went to the 1 first, and that's how we got the 1 inside of our set. Now, what we want to do is say left and right, and these are going to be two variables that are just going to do the same algorithm recursively in the left and right subtrees. So we're going to say node dot left and right equals DFS node dot right. So if that happens, we return true. But as you remember, in the first example, we had 4 minus 1 is 3. Is 3 inside of our set? It's not. So we had to add it to our set. So if this does not return true, remember we're going to have to add it to our set. So we're going to have to say set.add node.val. We're going to have our left and right calls here, and these will both return booleans. And what we want to do is say return left or right, because if they're both negative, we want to return, or if they're both false, we want to return false. If one of them is true, either left or right, we always want to return true, because that's where we found the match. And that should be it. We should just have to call our function, so call DFS root, and we actually could just return the call since it would return the boolean. And let's submit it and see what happens. Are we close? Oh, haha, I got a little mixed up there. This is how you initialize a new set, but this would just be an uppercase set. Let's try that one more time. There we go, and we solved the problem, and it's actually pretty fast. Hopefully you learned something new here, and if you need any help or something wasn't clear, make sure to comment down below, and I'll be sure to try to help you out. Peace. All right, that was one. That was kind of, was that shit? I don't know. Was that shit? Was that shit? I don't know. I don't know. Was it? Was it? Was it? Was it? All right, we got 32 minutes. I did not. I only took like 15. Like 12. Flatten into a linked list. That's not that fun, honestly. Unique binary trees is kind of hard. Second minimum node in a binary tree. Like, this was so like stupid. This is an easy problem. But more formally, the property root of val equals the minimum of the left and right subtree, the left and right values, node values. And the second one. Overall, this tree has 2, so 2, 2, 5, 2, 7. Oh, that's not correct. It has to be a 5 or something. Eraser. Let's say we're at the root here. 2. If we look left, we see that there's a 2. We look right, that's a 5. So between 2 and 5, what's lower? It's 2. Ding, ding, ding. Value of this is 2. The value of the root node is 2. Same thing here. But what's wrong with me? That's supposed to be a 5. This is 5. This is 7. The lower number is 5, so the root dot val is 5. So the current node's value is 5. And the answer, let's say answer equals like, this answer. In this case, the answer is 5 because let's say we had an array of all the nodes. Let's just say we counted out all the nodes. 2, 2, 5, 5, 7. I think it's a little too like, that was a little too complicated. I'm not gonna do that like fancy set and shit. You know the set. I could do it like, I don't think I'm gonna do it that way. Probably this is too complicated. I would just make a set, add them all to a set, turn it to a list. So our answer is 5 because 5 is, and the answer we return 5 here because 5 is the second smallest value in the total nums array. And I should put a counter example. Here's a, you gotta return -1, right? Can't wait to eat. Can't wait to eat. ANSWER answer? Some shit like this. Woo. Um, yeah, because I would explain these two problems. So 5 would be the answer because it's the second smallest number. Because it's the second biggest number. So 2, 2, 5, 5, 7. As you can see, 5 is the seventh. Oh yeah. Under ATL. Oh yeah, oh yeah, oh yeah. All right, we're back. As you can see, yeah, I think like what we could do. I think this is like pretty simple. I'm not gonna solve it this way because it's like overly advanced with this like the union of a set thing. But how I'd solve it before, I just do like add into a set, outside set, return it. If the set is equal to 1, yeah, I think I'm gonna do that. That makes the most sense. Bing, bing, bing. Okay. Given a non-empty special binary tree consisting of nodes with the non-negative values where each node of the tree has exactly 2 or 0 subnode, has true subnode. If the node has 2 subnodes, then the node's value is the smaller among the 2 subnodes. More formally, node.val equals the minimum of root.val equals the minimum of root.left.val, and root.right.val always holds. Given such a binary tree, you need to output the second minimum. What's going on, brother? What's good? What's good? Given such a binary tree, you need to output the second minimum value in the set. Second minimum variable. You must output the second minimum value in a set of all nodes values of the whole tree. Reply? What? What do you want me to say? What's up? What's up? Can you not hear me? I think you can. I don't know if I could type in chat, really. I think we're good here. It's a bit of a tricky one. And then I should try to record one more after this. I have a test tomorrow on DS, data structures and algorithms. What are they gonna ask you? Wait, give me a second. Let me record this. I'll try to help you out. I don't know. Hop on LeetCode. I don't know what to tell you. All right. Gran Fatty How? I don't know what that means, dog. All right, chill out real quick. Let me record this video. Should I turn off chat? I don't know. Maybe. All right, let's just start here. LeetCode 697. I feel like I should like explain stack and queues. Okay. Like a stack. Is LIFO last in, first out. So if we had a stack of these elements 1, 2, 3, 4, I don't know, 5. The last one in was 5. No, it's LIFO. Last in, first out. The last element we added was a 5, so when we pop it, 5 will come out first. So it would, like this. Every time you pop, it would add this one. And a queue is FIFO, first in, first out. Think about it like a queue, like going to McDonald's and you getting drive-through. That's a queue. All right, I gotta record this video, so bear with me here. I'll try to help you out in a minute. Understood? No problem, no problem. Are you subbed? Are you subbed? I think I know, drop a sub, man. You know what I'm saying? Maybe you are subbed. I don't know. It says you have 75 XP. I don't know. But I'm glad I was able to help. Okay, so let's record this video. All right. Hello everyone. Today we're solving LeetCode 671. All right. Hello everyone. Today we're solving LeetCode 671. You only sub at Subway. You're a hard bargain. Hard bargain. All right. Well, good luck on your test tomorrow. All right. All right. Hello everyone. Today we're solving LeetCode 671. Second minimum node in a binary tree. Given a non-empty binary tree Bro, I fucking hate reading these wordy ass questions, man. All right, hello everyone. Today we're going to be solving LeetCode 671, minimum, second minimum node in a binary tree. So the question description is, given a non-empty special binary tree consisting of nodes with non-negative values, where each node in the tree has exactly 0 or 2 subnode. If the node has 2 subnodes, then the node's value is the smaller among the 2 subnodes. More formally, the property of node.val or root.val is the minimum between root.left.val and root.right.val always holds. Given such a binary tree, you need to output the second minimum value in a set of all nodes values in the whole tree. If there is no such second minimum value, output -1 instead. All right, that question was extremely wordy, but what it's basically saying is that every node in this special binary tree will either have 0 or 2 children. And if it has 2 children, the node's value is just going to be the minimum between the left and right subtree. So as you see here, when we're at 2, we look to the left, there's a 2. Right, there's a 5. And so min of 2 and 5 is 2. So this value is going to be a 2. Same here with 5. The min of 5 and 7 is 5. So this is going to be 5. So here, I drew out the question here, and the answer should be 5. So let's say, since the question is asking what's the second minimum value of all the values in the tree, let's say we went through and we added all the values into an array. Something like this. 2, 2, 5, 5, and 7. Here, the answer is 5 because we want the second minimum. So as you can see, that makes sense. And let me give you a counter example. So let's say we had this tree here, 2, 2, and 2, 2. We would add all the nodes to an array. Let's say we had 2, 2, and 2. We want to return the second minimum. We can't return 2 because 2 is the first lowest and the second lowest. Actually, there's no second lowest because there's only one value here. So we should return -1. But our array has 3 values, so how can we remedy this issue? And I'm going to tell you. Instead of appending to an array, what we can do is append to a set, because a set can't have duplicates, so it will only have unique values. And we would just have to return the second number in sorted order. And if there's less than if there is one number or less, then we should just return -1. So let me show that here. Instead of an array, what we're going to do is add to a set. So let's pretend let's say this is a set. We'd add 2. And since sets can't have duplicates, we go to the left and we'd say 2, and there would not be another one. And at the end, we just have 2. Now we say if our set only has one value, then we should return false or -1 because there is no second minimum because there's only one option. And the same thing here. Let's go through here and pretend we're adding to a set. Wow, it's like connected for some reason. You can't delete all of that. Okay, let's not do that. So let's say this is our set, and we go through and we add every number. We add the 2. We go to the left, we see a 2. That's already in there, so we won't add that. We'll go to the right, we'll see a 5. 5 is a unique number, so we'll add that. We'll go to the left of 5 here to this 5. We'll see that that's a 5, but we already have a 5, so we can't add that. We go to the right, and we'd add 7. So our set consists of 3 numbers, 2, 5, and 7. The answer is 5 because it's the second value here. But unfortunately, sets don't have indices, so what we're going to have to do is convert this set to an array. So we could just, that's easy, just wrap it in a list operator or in a list data structure. So the list will essentially be a list of unique values. And all we have to do is return the value in the first index, because it's 0, 1, and 2. the first index always holds the second value, and we'd return that number. And there's one caveat: since this isn't a binary search tree, we want to make sure we sort this list before we return the first index, because it might not always turn out to be sorted like this. All right, so let's actually get into the code. How would we solve this? So as you remember in the beginning, we want to have a set. Let's just call it set equals set. Next, we want to create our depth first search function. So depth DFS is going to take in a node. What we're going to do now is have the base case, since this is a recursive function. And every time we hit a not node, let's say we're at 2 and we went down to this null node and this null, we want to just return because we can't add anything there. So we're going to say if not node return. Next, what we want to do is say node our set dot add node dot val. So that's essentially adding our first number. So in this case, we'd be adding the 2, and then what we want to do is go left to this left subtree. So to do that, we're going to say DFS node dot left. That's going to go to the left subtree here too. It's going to add this to our set. It's already in there, so the set won't change. And next, since we're in the second recursive call, we're going to try to go left and right. But they will hit our base case here and we'll return back up. Now, since we've explored the whole left subtree, we want to explore the right subtree. So we're going to say DFS node dot right. So if we go node dot right, we'd add 5 to our set. New call, so we'd go left, add 5. 5's already in there, so we won't do that, and add 7. And at the end, our set should have 2, 5, and 7. Now, what we want to do is convert our set here to a list. So we're going to call it array. Array equals set inside of a list. So we're going to say list set. So now this is now an array inside of a set, instead of a set with unique values. Next, what we want to do is sort to make sure the second value that we pick is always going to be the second minimum, because we're sorting in ascending order. So array dot sort, and now return array at the first index, and that's the first one. But as you remember, there is a case when we return -1. That's if the set doesn't even have enough values to equal to even get a second minimum value, like in this case here where there's only one value. So if we're looking at unique values, all we have to do is say if the length of array equals 1, which means there's only one unique value, we just have to return -1. And this should be good. All we have to do is make sure we actually call our function, because our set will be empty if we never called it. So we're going to say DFS root, and we should be fine. Let's run this, double check everything. I think it looks good. Let's try it out. And there we go. We solved the problem. Hopefully this was clear and concise. And if you have any questions, comment down below. Peace. All right, that's 2 problems. Can we hit another one on some insane shit? On some insane shit. Can we hit another one? I have a whole bunch of videos to post. What's the next question we should do? Unique binary tree? Fucking hell no. Post order traversal? This is pretty easy too. Given a root of an in array tree, return the post order traversal of its nodes. Post order is, am I sweating? Hot fucking So post order is always go left. Post order means we go left, right, then do the operation. So we should go left, 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 right, print the operation. So 5. Turns back up. This goes right. 6. Goes back to 1. We go right now. So we go 4. Left, right, base case. There's no dot left. And I think it's just children. We should just like. Oh, I returned it inside. That was kind of gangster. Can't hold you. There's no chosen. We're just going to return the node in a list. Like, I did this, like, if there's no chosen, return the node in a list. And then res equals empty array for C and children. Res plus equals depth first search of C. So add all the children. Yep. I don't want to explain this one. I feel like it's complicated. It is a much like easier. The post order traversal of its tree. How would we solve this? I don't know. Go left. I don't know. I just don't really feel like doing this shit. Because we just go left. We make an empty array, not node return. We don't go left. We go for node dot children. Did I solve it that way? I kind of like this way I solved it, but I guess we could. I think it would work that way. We just have to go left. Not children. I don't think we need to do this. We could probably erase this. And just say for C and node dot children, res plus equals res empty, so it's going to left. Bro, honestly, I'm not sure how I usually solve this other way. I don't know. If I just said like array equals this, and then we say DFS node dot def DFS node. If not node return, then we just go I think we just go DFS node dot left. This is post order, and DFS node dot right. Wait, no, there is no dot right, dot left. Or C in node dot for C in node dot children. For C and no dot children, we want to print the 5 first, so we got to go. Yeah, for C and no dot children. For C and no dot children, we want to go EFS, EFS into that child, depth first search into that child node. So it'll be 3, then it'll be 5, hit the base case. And do I do like array dot append dot val? Is that what I'm supposed to be doing? Children, so we go left, then return. There's no children. No children. It should say no data pin val. In that call, recurse back up to the 5. Now, I mean, recurse back up to the 3. Now, 3 still going as children. I'm pretty sure that's right. Like, then just return. Okay. EFS. Some shit like that. I mean, I don't know. I'm getting. Is that it? Oh, it's it. Yeah, that was easy. In array tree. What the fuck? What does that even mean? What the fuck? What is that? Oh, okay. I have like a lot of trees. Okay. And array. An array tree. Okay. That was pretty easy. We got 1 minute left. I feel like I could definitely snack this one. Oh shit. Today. This thing I'm gonna watch. I got a bad bladder. We can only sleep sometimes. We can only fucking. This last one. Make some food. It feels so fucking good. Sure feels so fucking good. I don't know. I guess like type shit. I don't know. All right, bro. Boom. We're back. One, three, two. 1, 3, 2, 4, 5, 6. 3, 2. 4. Boom, let's go. Boom, boom. Wait, what? Wait, what number is that? 850. What is this? I think it's a scam. Remember. Isn't this like scam likely? All right, let's solve this problem. Inner tree. Only has dot. There's only dot left. And there's no dot left. All right, it's only. There's no dot left and dot right. It's only. Here's this reverse to children. I'm gonna have an array and then we're gonna check. How long have I been streaming for? God, 4 hours? Holy fuck. It's an insane session. Got left and dot right. As we know, post order. Okay, I think we're good. Because I'm gonna say like post order. Probably should have like some way of like typing or something. Post order. Traditionally, DFS, depth first search goes left, then right. And post order means you're going to go left, right, then after both of those are completed, you're going to do some operation. The last one I need to do. Come back, because I don't want to record anymore. I just want to edit. Take a break until like, if I take a break, it'd be until like 5 o'clock down there. Do I need to do anything? I need to. I did not say I was going to edit today, though. I never said that. I can read the graph chapter after this workout. Anki lead code. Okay, that's not bad. All right, let's just do this. Okay, it's not bad. Okay. I don't really like. I don't feel like. I gotta edit. I don't feel like editing it all today. I'm just gonna record. All right. Bang, bang, bang. All right, hello everyone. Today we're going to be solving LeetCode 590, in-array tree post-order traversal. Given the root of an in-array tree, return the post-order traversal of its nodes. An in-array tree input serialization is represented in their level order traversal. Each group of children is separated by null values. See examples. So as you guys can see, the result array would be 5, 6, 3, 2, 4, 1, because that would be a post-order traversal. And if you don't remember what post order is, we're going to quickly go over that. So post order means like post meaning after, and in a depth of research traversal algorithm, we go left subtree and then right subtree, and then we're going to do the action after, which is appending the node to the array. The tricky thing about this question is that typical DFS algorithms goes left right, but as you can see, some nodes have more than two children, so it's more than left and right. So we're going to have to iterate through their children from left to right, if that makes sense. And if it doesn't, we're going to quickly go over it. So what we want to do is go start at the root 1, and we want to go left, left, and here we're going to try to go left one more time, but as you know, this would be null. So we're going to return up. That would be the base case. Then so we went left, and that's its first child. Now we're going to check, does it have any other children? It does not have any other children. So what we're going to do is append this value to our array. So we'd have a 5. Next, we'd recurse back up to the 3. So now we are here at the 3. We've already explored its left subtree, so now we're going to explore its right. So we're at the 6 now. Let me quickly erase this arrow. We're at the 6. It's going to go left, right. Both of these are null, so it return back up. That's our base case. And since we went left and right, and we're doing post order, so every time we go left to right, we're going to print the node. Here we print 6. We recurse back up to 3. We've explored all of its children, so now we go to the 1. We've explored 3, so now what we want to do is explore its next node. And the next child from 3 would be 2. We'd go to the 2 here. So now we're at this node here, 2. We'd go left, right, and as you remember, if there's no children, that's our base case, we'd return back up. So we'd print that node. Now, since we've explored the left subtree from 1, the middle one, now there's only one child left. So we'd go to the left subtree. Same story here. It goes left, right, both for null, return back up. And now we'd print the node, so we'd append 4. And now since all of 1's children have been explored, we're just going to append 1. As you see, 5, 6, 2, 4, 1. And if we look at the res array, 5, 6, 3, 2, 4, 1. I forgot the 3. Okay. I know I forgot something. Something just did not look right about that. I was like, I couldn't put my finger on it, but that makes sense. Okay. All right, so here we are. We're going to quickly go over post-order traversal of this array tree. So post means after, and in typical depth-first search algorithms, we want to go left, right, then print the node. The only issue here is that there is no left and right because any node could have more than 2 trees. So what we're going to have to do is iterate through their children, which is in an array. As you can see here, self.children, and it's an array, and that's going to hold all of the children nodes or child nodes. We want to explore their children, go to the right, then print the node. So as we see, we start at the root 1, we go down to the 3, it traverse its children, 5 and 6, we go down one more time to the 5. And now from the 5, we'd look and we'd say, let's go to its left subtree. That's null, and that's our base case, so we'd return back up. Can we go to the right subtree? That's null, return back up. So we went left, right. So now the post order, after we go left, right, we always print the node. So we're going to have a 5 here. We recurse back up to a 3, so now we're here at this 3. And we've explored its first child. Now we're going to go to its second child. We're going to go to the 6. We go and check its left subtree. We see that's null. It'll return back up from the base case. Right, same story. We went left, right. Now it's time to print the node. 6. We recurse back up to 3. 3 has explored all of its children, left and right. So we're going to print 3. Next, we recurse back up to the 1. And we're going to go to its next child. We explored 3, so now we're going to explore 2. Same story here. 2's left children are null. They don't exist. So it explored everything there, and we'd return to print 2. Next, since we've explored this path, we want to explore the 4. We see that 4 has no children. It can't explore that. So we've explored all the possible children, and we'd return 4. And as you can see, this example, 5, 6, 3, 2, 4. And the answer is 5, 6, 3, 2, 4. Oh, I almost forgot. After we explore the 4, we recurse back up to the 1. And we've explored all of 1's children, which are here, 3, 2, and 4. So now what we have to do is print 1, and we'd append 1. So you see 5, 6, 3, 2, 4, 1. 5, 6, 3, 2, 4, 1. Perfect. So now we're going to get into actually coding up the solution. So as you remember here, we'd have an array. This is what we're going to return at the end. Next, we're going to have a depth first search. So we're going to have a function. We're going to call it DFS. So define function and DFS, and it's going to take in a node. Our base case is if not node return, because let's say we're at the node here 5 and we go, there's nothing on the right, there's nothing on the left. We want to return up because we don't, if there's no node, we don't want to explore that. Next, what we want to do is say for C in node.children. And what this does is going to iterate over all of the current node's children. And inside of here, we want to say DFS C. And then after we've went and explored all the node's children, we want to array dot append node dot val. So this is like the bulk of the solution. So I want to quickly go over that and make sure everyone understands. For C and children, so as we can see, when we're at 1, the first child is 3. We'll explore that. Now we're at 3. It's going to do the same thing for C and children. Go to the 5. For C and children, there is no children, so return back up and print the 5. And as you remember, we already traced this whole thing, but I just wanted to go over that one more time. And it should iterate over every tree in the node. And this will be an O of n solution because we visit every node once. Next, we want to call our function, so DFS root, and return our array. And everything should be nice and sweet. Let's try it out. And there we go. We solved the problem, and it's actually has a pretty good runtime. So hopefully you learned something, and comment down below if you need any help. Peace.